Okay, so here we're going to introduce what are Hamiltonian circuits and paths. All right, so what you see in front of you is from our textbook. Right, it says a Hamiltonian circuit is a circuit that visits every vertex once with no repeats. Being a circuit, it must start and end at the same vertex. A Hamiltonian path also visits every vertex with no repeats, but does not have to start and end at the same vertex. Now, you might seem, well, didn't we cover this already in Euler circuits and paths? Well, if you recall in Euler circuits, Euler paths, we talked in terms of edges, right, where we visit every edge, right? But this is not what we're going to take a look at, right? Think of the difference when we talked about Euler circuits. We talked about a postman trying to deliver all his mail through every house. And this Hamiltonian circuits and paths is more like a delivery man, or later we'll see what's called the traveling salesman problem. So delivery, where you have your vertex are the the homes where you're delivering packages, right? You don't necessarily need to go through every street. You just need to make sure that you hit every home that has a package that needs to be delivered. Okay, so let's take a look at some examples here. Let me switch over. All right, so what we see here is we see a graph. All right, and the first one is we're going to take a look at a Hamiltonian path. Okay, so we have a graph here, right? We have 1, 2, 3, 6 vertex, and then we have several edges. What is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 edges, right? And we're going to look and just kind of map out a path here. All right, so here I'm going to start at A here, right? So here, let's see here. So let's kind of bold the color here, but something that'll be in contrast here. Okay, there we go. Okay, so if we start here, right, we visit that first vertex from A to B. And then now I'm going to scroll over to C. And then I'll make my way down to F. All right, so you see this would be the path that we take. And again here, the goal is that we look at that we visit every vertex, right? I don't care about the edges, right? And when we're talking about Hamiltonian paths and circuits, all we care about is that we make sure we visit every vertex here. So here, and now we'll go here. All right, and see, notice starting at A, right? We make our way through A from A to B, B to C, C to F, and then F to E, and then E back to D. Notice there are still edges that have not been visited, right? But that is perfectly fine when we are dealing with a Hamiltonian path in this case, right? Much different from a Euler path. All right, now let's take a look at scroll over here, a Hamiltonian circuit, right? And see what that would look like. So here we have a graph, right? We have 5 vertices, right? And again, what a Hamiltonian circuit would look like. Let's say here, I'll start at G, right? And then from G, I'll go to J, right? So let's highlight my path here, right? So from G to J, and then from J, I'll go to I, and then from I, excuse me. And then from I, I'll go to K. And then from K, I'll go to H. And then from H, I'll go to G. Okay. And again, we have highlighted here a Hamiltonian path. Again, notice similar to our example, the previous example, we have a Hamiltonian circuit here. And again, notice in our previous example, we looked at a Hamiltonian path. Not all edges needed to be visited. Okay, the main thing is that all vertices, right? Our focus is on vertices here. All right, now what will come up here in our next topic when we talk about what's known as the brutal force algorithm, right, is this idea of a solution to what's known as the traveling salesman problem. Right, and that's going to involve, so we're going to take a look at these weighted graphs, right, where each edge has a corresponding weight, and we want to minimize kind of our path here, or our circuit, I should say, through this graph, right? So that is what's known as the traveling salesman problem. So going back to our book here, our textbook. Okay, so we're going to take a look at, if you look here, what's known as the traveling salesman problem. So let's say that, and again, not necessarily related to salesmen, but let's say that, you know, you have a job that requires you to visit different cities for whatever reason, right? You give talks, you go visit different job sites, whatever it may be, all right? And you want to kind of map out your circuit here, where you want to travel to each location, but you also want to minimize the cost, let's say. All right, and again, you only look at one variable, right? You're just looking at cost, right? You want to start wherever your home may be and then map out the different locations and then return home, right? You want to, so not a path is not going to be what we're looking at here. Instead, we're looking at a circuit because we do want to wind up back at home. All right, so the traveling salesman problem would be like, all right, what would be the most cost efficient, right? If that's the variable that we're focusing on. All right, and then the next video we'll look into the brute force algorithm, which will give us a way of, which will show how to come up with the most efficient path here. All right, thank you.